for the grit removal is on a rail system running on the bottom of the tank. Again, that's set up on a timer to run on a 15-minute on, 15-minute off, which can be adjusted through SCADA to remove the grit from the system. Once you get water into the tanks, the air can be brought in. There's 4 header pipes that feed down into the tank itself. The isolation valves for those are directly beneath where you're standing. There's a valve on each one of the headers, manual valve. If you need to shut one system off, you can manually isolate it from the rest of them. And from that point, the wastewater flows off to the launders and is discharged from the far end of the tank. The sluice gates that control the flow into the tanks can be operated here locally, or they can be operated through SCADA. The control for it, the disconnect is located on the wall. The control for the operator is located directly here, and you can get a visual on the position of the gate itself through the rising stem as the gate is opened. Any questions on anything out here at this point? I wanted to mention the gas monitors right now they have been set up, but they are not operational because of the fact that the covers are not in place for the tanks, so there's really no need to be monitoring for gases out here. So these would remain off until the tank covers go into place.
What are the covers made of?
I believe they're the same material as this, yes. On the far end of the tank, the dewatering pipeline is the 6 or 8 inch line that's coming up off the end, which would be connected to your drainage pump for dewatering the tank. And the fiberglass line that runs out over the center of the tank is the odorous air removal device. Once the biofilter goes into operation, then you'll be removing all of the gases from the top of the grit chamber off to the biofilter for destruction.
That back end will also be covered?
All the way out to, at least to the end of the tank. I don't believe that I don't know.
The question is if that's where we're going to hook our pumps up to.
Okay, any other questions at this point about the process? The airflow lines, the airflow monitors are located directly on the railing. Straight in front of me, there's the yellow boxes there that are indicating the airflow into each one of the chambers. Again, the blowers are rated for 600 CFM. Normally with one blower online feeding to both tanks should split the flow between the 2 tanks at 300 CFM to provide the aeration for grit removal. All right, let's take a walk back inside. On the grit collectors, the chain mechanism with the buckets rides through the bottom of the tank on a set of rails. The control for the equipment is on the side. There's a handoff auto switch for both the grit washer as well as the grit collector. The chain is on a continuous rotation, bringing the grit up to this position here. And then as the grit buckets rotate up over the top, the grit is discharged into the trough within the mechanism itself. There's a set of spray bars on the top that will actually clean the buckets once they've discharged the material. There's the counterweight mechanism, which is used to keep tension on the chain, is set up at this point. We've got 500 pounds of concrete block sitting in the box to maintain tension on that chain. As the system wears out, you'll see that the chain will develop some slack. At this point, this has been adjusted to maintain proper tension on the chain, and it is up near the top of the positioning, so that once the chain starts to stretch, I think what will have to happen is you'll have to remove a link of chain from the system That will then drop the take-up shaft down and allow this, allow the take-up counterweight system to, again, apply tension on the chain. It's strictly a weighted mechanism that's running a cable up to the take-up shaft to apply tension on that chain. Directly on this side of the unit, there's a water spray. There's a solenoid valve that's interlocked with the drive mechanism. So when the drive mechanism comes on, the spray water will come on to clean the buckets during the operation. Once the grit is discharged into the trough within the unit, the wash water from the sprays will assist in carrying that material into the grit washer. The grit washer is used to remove the organics from the grit. The lighter material will be flushed off and discharged back into the process through the drain line here. There's a weir plate within the grit washer itself that's been set at the lowest position in order to try to provide as much drying capability as possible on your grit, to keep the grit as dry as possible before it's discharged onto the conveyor belt. That can be adjusted. We'll see how things go when we start the process up. There is also a spray water line attached to the grit washer itself to provide additional wash water. We'll see when we start up. I suspect that we may not be using that spray mechanism. I think there may be enough water coming off the grit collector itself in order to wash the grit. We'll see what happens with that. The grit washer itself is interlocked with the conveyor system, so that you need to have the conveyor system online. Same process, starting at the downstream end at the roll-off container. Put the roll-off container online, put the belt conveyor online, then bring the grit washer online. And then the grit collector itself will be run off the timer that's set up in SCADA. Once the programming is completed, which should be over the next few days, we will then be able to set these up so that they can be run intermittently along with the collection mechanism. Okay. Any other questions at this point? The operation of this conveyor is very similar to what's occurring with the Screeney's conveyor. You've got the same type of controls here. We got a handoff auto switch with a start-stop station located directly at the conveyor. When you go to automatic, the conveyor can be run through the SCADA system. You get an emergency stop switch if in fact you need to shut the system down. It also has the safety cabling around the outside, which is attached to the emergency stop switch on the other side of the conveyor itself. The material that's being deposited on this from the grit washer. The grit washer discharges through the neoprene chute and discharges onto the conveyor belt, and this takes it off to the roll-off container, which we spoke about a little bit ago. Operation of the conveyor is identical to what you've got on the Screeney's conveyor. All right. At this point, we'll take a walk through the electrical room and then off to the par shell flume. Blower operation is controlled here. Again, you've got the VFDs. It's a variable frequency drives in order to adjust the speed of the blowers. Running in hand as they are right now, you've got control right here at the panels. In automatic, that transfers control to SCADA, and you can modify the speed of the blowers through SCADA. Any questions on the headworks itself? From that point, the flow runs into the combined channel, which is directly behind me. Off to the left-hand side, you can see the operator for the control gate that will be taking the wastewater in from the west grit facility. The channel that's partially constructed will eventually be tied into the west side of the operation. The chambers directly behind you will be modified. The biofilter is going to be installed in one of the chambers as part of the ongoing changes within the plant. The flow from both the west and the east is combined in this channel, flows directly behind me, down through the par shell flume, which is located over here on my left. The flow sensing devices are located within the channel similar to what you have on your existing Parshell flume. The sampler is grabbing a sample at the Parshell flume. The signal from that flume itself is being fed into the sampler, so it's a flow proportion sample, exactly as what you've got running right now. Eventually, as we bring the system online, there could be potentially flow through both the east flume as well as the west. There's some programming being done right now in order to be able to pick up the flow signal from both of the flumes so we get an adequate flow measuring flow signal to the samplers, both here at the primary end of the plant as well as the primary effluent and the secondary effluent. That programming is being done as we speak. So there could potentially be flow through both of the flumes at the same time if we get into a high water condition during startup of the East Grit, because again, as I said, the capacity of the East Grit is designed for 80 MGD. If you're running above 80, there will be a channel available within the West Grit facility in order to run flow through during reconstruction of that building to get you your higher capacity required. Any questions on anything here or excuse me, or anything that we've spoken about this morning? Hearing none, I say thank you.